All right, what's up, everybody? This is Dr. Tracy too. So I'm here with EE135 from Electrical Engineering Department. So this is one of the first video recordings we're going to do for our class. We had some discussion about trying to do this every Friday. I'm not so sure about that, but for sure this coming Friday, you should be watching it right now. Okay. So what have we done with the course so far? Pretty much has all been reviewed, went through the syllabus, and yeah, I know the name of the course is called Renewable Energy Sources. We haven't really talked about that much, but again, like I said before, the key point here is energy sources. So before we can even start talking about renewable energy sources, we kind of have to understand, well, what is energy to begin with, right? And this is what we're going to kind of talk about today. I know everybody's always says, oh, well, I know what energy is. I learned that when I was, what, 5, 10 or something. But there's a lot of different sources of energies out there. And then we kind of have to go over at least the ones that are pertaining to what, power generation, electric generation is. So I really want to talk about energy as a whole before we get to renewable stuff, because there's a lot of non-renewable energies, and you kind of have to know all that before you can even kind of compare what renewable energy sources are going to be like. Okay. One thing I forgot to say is that I'm going to take these videos, I'm going to split it up into like maybe 5 or 10 minute intervals rather than doing a whole like 50-minute block. That way we'll put it into kind of bite-sized pieces, so you don't have to like always be searching your bar or one little spot that you want to read or listen to over again. Okay, so other things I'm using, I'm actually at my house. I'm using a webcam, and I have my microphone set up with some stage lights, so hopefully it looks a little bit better for you guys. I also like to have a picture of myself in the lower right hand corner, so we can make it a little more personable. I think most people actually just have the screen up and don't have a picture of themselves. But I personally don't like that. I like you guys to see my facial expressions, me smiling, scowling, and playing around a lot. I mean, this is pretty much the exact same thing I use for my Twitch stream, and I think people find it a lot more entertaining like this. So give me some feedback. Let me know what you think about that, and we'll go ahead and kind of test out this today. All right. So first thing I want to ask is, what is energy? All right. There on the screen, you can see that there's a website, right? This is the U.S. Energy Information Administration. Pretty much, this is kind of the Department of Energy putting up a website just for normal people like me and you. It's kind of like a little small study guide to show us, what are different type of energies used, what do you expect to see in the industry. I kind of want to go over all of this because this is a really important topics that you're going to see if you ever work in the power industry. The idea that all you guys in this class, so you're all going to enter the power industry in some way or another, right? And so this website, which I'll obviously will put on Moodle, it's a good starting point to kind of learn all the different energy sources and generation stuff for the power and oil and gas sector, right? So it's not that much information. It's kind of down to earth, so no, it's normal engineers like me and you can understand it. You don't be like a scientist or anything. And in your own free times, look over it, please. It's set up to each page is each website each section of the website is maybe 1 or 2 pages, so it won't bore you to tears. All right. Maybe if you're like me, I actually find it kind of interesting trying to learn all this stuff. So for this one, we're just going to ask, what is energy itself? If you can see my mouse right here on the left-hand side, there's a whole bunch of different categories of materials we're going to look at. We're just going to look at this first section, right? So what is energy? Energy is the ability to do work, it says, right? So energy means you want to light a light bulb, right? You want heat a heater. You want to stay warm, right? Humans been using the energy sources since they figured out that you can light fire, right? So some very common forms that we use is heating the house, right? We call that right here thermal heat, right? Light is another one, radiance, kind of like a light bulb. Or another big example is the sun itself, right? Then we have motion and kinetics. This is kind of like driving a car or moving an object or moving a box, right? Then we have electrical. That's our specialty, right? We're electrical engineers. This is electrical energy. This is the electrons in the wire having the movement and of the electrons through a resistor, right? That creates some type of electrical energy that we could then use. Chemical energy. This is simple. This is just like gasoline, right? This is when you have some type of chemical bond that holds molecules together, and then through some process, mostly burning, they break apart. And when they break apart, that's when you have a release of energy. In the case of an explosion, it's a release of gas, of heat, which we then can harness to whatever we want to use, right? Either driving a vehicle or heating the house, right? Then we have nuclear energy. This is actually very new in the whole idea of humanity, right? Probably what, like, God, 60 years ago they figure out nuclear energy. This is kind of splitting uranium atoms and then watching this huge burst of heat and energy that we could then harness somewhere else. And last one is gravitational energy, right? That's just the gravity from the Earth. You guys should know that any mass has some type of gravitational force attracted to each other. Even if you have two balls right here, like tennis balls next to each other, they're going to want to kind of go towards each other ever so slightly, right? Obviously here, the gravitational force of the Earth will far outweigh those. But in like a pure vacuum outer space, they will eventually tend to each other. So, yeah, that's good enough for that. We use it everyday life, right? I'm currently here making a jump shot, or sending astronauts into space. Obviously sending astronauts into space, we got to fight the gravity. We fight gravity by using a rocket, which then uses heat and thermal energy and puts it into kinetic motion, right? So, from a physical standpoint, you remember old physics 11A and stuff. There's two types of energy we always look at: potential energy, kinetic energy. Potential energy is energy at rest that has, like it says, the potential to actually do something. For example, that we know is water in a dam, right? You have the water in a dam, it wants to flow down, but we stopped it. That pressure, that water pressure that wants to go, that's potential energy. We haven't used it yet, so when we use potential energy, that turns into kinetic energy, or called working energy, right? One example is if you take a box and you raise it and put it on a shelf, right? You use kinetic energy to put it up there. Now the box has potential energy because it's going to want to fall down, right? So you can always release that potential energy by letting it fall down, right? And then you could tie a rope or a pulley to it, and then it'll lift something else, right? That's changed potential energy to kinetic energy. Okay. For us, as power generation, we could say energy sources can be categorized as renewable or non-renewable, right? Renewable sources kind of like something that's going to come back readily, right? The wind will always be here. The sun and solar energy will always be here, right? The water will always be here, right? Because it'll always rain in the hill and go all the way down to the ocean and can repeat the cycle over and over again, right? Will be non-renewable. That's energy sources that that cannot be easily replaced, right? The biggest one is kind of oil or coal, right? Those take millions of years to form, and then we can't just say, oh, well, let's just wait till tomorrow and it'll come back, right? I would say probably, yeah, nuclear fuel, that's probably also non-renewable as well, right? Just to show categories, right? And of course, we use both of the renewable and non-renewable sources to make electricity or electric energy, right? Here, when people use electricity in their homes, they're probably generated from another source. We already talked about this. You have to burn coal or natural gas, sometimes a nuclear reaction, or you gotta have a dam that lets water through. So some type of mechanical force, some type of energy is being transferred from this coal, natural gas, or nuclear fuel to electric energy, right? And that's what we do, right? That's what we're responsible about. Okay. Other things that electrical engineers don't really do, but the gasoline in your car, right? That's another way of converting energy. Okay, here it says crude oil and biofuel also can be used, for driving your car. Okay. Sure, there's a chart down here. There we go, right? So here's a kind of a chart to show the new U.S. energy consumption by energy source in 2016. It's to note this is a total consumption, 72.4 quadrillion BTUs. We'll talk about what the BTUs later. So here we can see 37% came from petroleum, That's like gasoline. 29% came from natural gas. 15% coal, 9% nuclear, and renewable energy is 10% everything else, right? So you can see as a whole, renewable energy is pretty. It's not a non-factor anymore because 10% is a big deal. It used to be like 1 or 2%, but still is dominated by fossil fuels, which is all three of these: petroleum, natural gas, and coal. I know you guys don't really see it too much here in California, but California is a special place where we're actually trying to make renewables work. Back in the South, no one even cares about that. It's literally all natural gas, coal, and some nuclear, right? So just to give you like a different point of view. Okay. So here's your non-renewable energy sources: petroleum, hydrocarbon gas, natural gas, coal, and nuclear energy. Right up here, we talk about renewable energies. This is solar, geo, wind, biomass, and hydropower. Okay, so kind of just to give you a overview. So, forms of energy, right? So again, we have potential kinetic energy. This kind of gives you some examples. Chemical energy. This is bonds of an atom, batteries, right? Petroleum, stored energy in the chemical bonds that we need to break and then later release it as energy we could harness somewhere else. Mechanical energy. I already totally forgot. A compressed spring. That's a perfect example. It wants to shoot out, but we're not letting it, right? So it has that potential energy ready to do work. Stretch rubber bands are actually a good one too, right? Nuclear energy. This is stored energy in an atom that wants to split up later, and then once we split it up, energy will be released, right? Gravitational energy. That's what we're talking about, putting in a box on top of the shelf and letting it fall, right? Kinetic energy, radiant energy. This is just the sun, right? And visible and invisible lights, gamma rays, other radiations. This is all some type of energy, pretty much mainly from the sun, that comes to our Earth, and then we could either harness it or what actually we use it for is, what nature uses it the most is to heat the Earth, right? That's the whole reason why we have a sun and why we could live on Earth. It's because the sun actually heats the Earth up, so it's a livable temperature, right? Otherwise, you go to like Uranus all the way over there, it's frozen solid planet, right? Because it's too far from the sun, right? Thermal energy is just heat, right? You turn on the stove, you burn your hand, oh, there you go, thermal energy. Your hand just, took it all. Motion energy. This is pretty much just a car driving down the street, right? Or you're throwing an object across the room because you're rage quitting and something. I didn't think about this, but sound, right? Sound is also kinetic energy, right? Because you have to have a sound pulse or a air pressure pulse that goes through the air so somebody else can listen to it, right? So that has to have kinetic energy to move the molecules through the air so somebody else could hear the sound from a speaker, right? And of course, like we know, electrical energy, right? This is the electrons flowing through the wire. All right. Sources of energy, right? This is kind of retelling the same story, but we'll look over it again. It's a nicer graph. This is your consumption by source. So in the U.S., we're talking about production. Now we're talking about consumption, right? So the idea with consumption is this is how much energy we use as a whole from the United States for 2016. So some of it came from biomass, hydro, geo. This is all renewable stuff, right? And again, most of it comes from non-renewable. Here you can see, well, what do we use biomass for? Heating, electric energy, transportation. Hydro is pretty much only for electricity, right? We can't really use that for transportation as much, right? Geothermal, naturally heating makes perfect sense, right? Because, it's hot energy from the earth. You can also harness it as electricity. Wind is pretty much electric, right? I wouldn't count sailboats as, transportation because nobody uses a freaking sail nowadays to ship cargo, okay? Right. Solar and I guess other, we'll have to see what other is, but solar is just pretty much PV panels, solar panels on top of your house. And also heating, right? What's another way we could use the solar energy? Greenhouses, right? Somehow we could get the sun to shine in and trap it, and then the temperature will rise. There's a lot of houses that actually naturally are built to use solar energy to heat themselves during the winter, right? And then on the other side, we got petroleum, natural gas, coal, right? These three are pretty much used for manufacturing, electricity, transmission, all over the place. And then it's funny to note uranium, which is for nuclear, is actually only used for electricity, right? We don't use it for cars or transportation, right? You you might be able to argue we use it in the military for an aircraft carriers and submarines, but even then, they actually use it to convert to electricity, which is then used to run electric motors. So really, it only is for electricity. Okay. Lastly, let's look at laws of energy, right? This is pretty obvious for most people. Energy can never be created nor destroyed. What does that mean? We're never actually saying, I know people say we need to create power. That's technically not true, or create energy. All we're doing is we're changing a medium, the energy from one type to another type, right? We always have energy stored in coal. We always have energy stored in petroleum. The sun has energy that is constantly radiating out to us. The wind has some type of energy as the wind blowing, the molecules, the wind blowing, they have some type of inertia with it. And that came from somewhere else, right? So all we're doing is we're harnessing this type of either stored energy or like wind or sun energy and converting it to electric energy, right? So it's never like the energy never goes poof or never just gets created. It's just always transferred from something else, right? And here, that's what it said, converting more from energy from one to another. Now, the big trick here is when we convert stuff over, efficiency becomes a big deal, right? Because everybody should know that you can't have perfect 100% efficiency all the time, right? When you convert from one energy source to another, it's not, you're always going to lose something, right? There's always going to be some type of losses you need to take into account. And depending on what type of energy transfer you use, that could be really efficient or not efficient, right? The example over here they use is the human body, right? Apparently, I didn't realize this, the human body is 5% efficient. So the amount of food we eat, if you think of calories and pure energy, we only actually use a 5% of it to do like actual work, like movement and typing on our computers or like playing football and stuff, right? I want to say the majority of the energy used in your body is to regulate temperature more than anything else, right? And I think that's why, if you're Eskimo up in Alaska playing with the polar bears and the penguins and junk, you kind of need to eat a lot of food. Like I think they eat like 5,000 calories a day or something crazy like that. That's because they constantly have to keep their temperature of their body up, right? Versus over here, we don't need to do that, so we all just get fat when we eat a bunch of bad food, right? Okay. So I think that's it for the energy thing, right? Oh, I forgot energy transformation here, right? It's just a nice little picture to show you. Apparently, you eat ice cream, you better go ride a bicycle to burn it off, right? The sun energy will grow trees, right? Which then we could use for something else, like Christmas. Gasoline turns into car driving, and electrical energy, in this case, we could use for our oven to bake a cake. Okay. So I think we're cut off the video here, and then we'll start up next with this units and calculations and whatnot. Okay. So stay tuned for part 2. I'm off.